Welcome. This is Education Without Borders. And in this lesson, we want to learn the importance of the site of a building, where you locate a building. Many developers have sometimes very limited choice of where to locate their buildings. But there's a lot of difference between the behavior of this building or this structure between two different sites. For example, in this lesson, I want us to concentrate on what challenges do you anticipate if you change a building location. You could have a site, you could have a very big piece of land. On one side, it is level, and then it slopes gently over a hill to a river. Very beautiful piece of land. But it is important to understand when you choose the location of your building structure, the two will behave differently. Remember that a building is seated on the ground, and the ground has to support this building or this structure. So we have a law in physics. It's called Newton's second law, which states that action and reaction are equal and opposite. What that means, if we apply to this scenario of our lesson, is that the force the building is subjecting my ground to, there will be an equal and opposite force that the ground will exert on my building, and when the two of them balance, or then you have a stable equilibrium. But if you find that the building force, the force that it's exerting on the ground is much more, then that building may sink. Therefore, the two scenarios of allocation could be, the extreme condition could be a building on a rock as opposed to a building on the sand. So follow this and we'll learn one or two lessons on how to mitigate and even how to identify if the faults or the causes of a weaker ground are cause to worry or not, and how to repair and retrofit. Keep following, keep learning. This is Education Without Borders. Let's talk about the real buildings. We are talking about two scenarios of a building with the same design, and we have a choice of either putting it on an upper level or on a lower level. So if you look at that building, if you look at the slope, the topography, the ground is sloping that way. And even as you drive, you find that you're still at a lower level from the road, from the main road as shown there. And you are deciding that you want to put another building exactly similar design, but at a lower level. Let us see what that then means. When you do so, then you are talking about two buildings doing a lot of landscaping. There's a lot of landscaping to be done so that you can be able to drive. What I'm showing there is our first building, which is at a higher level, and this is the second building, which is at a lower level. And you have to access, that's the gate. You must be able to access from the main road to the gate. Then you make a choice of either coming down this way to this building or driving up there to the building at the upper side. And this is a perspective as well. You can see this is the gate we were showing on my foreground, and the first upper structure is there. It is still at a slopy ground, and the second building, exactly the same design, is at a lower level, and as you can see, is very beautiful. The ground is sloping, but you need to be very careful about the drainage, because there's a lot of water, underground water. And if you're not careful with the drainages, then you find all this water will go to the house or below the foundations. There's a lot of underground water. So you have to be careful about that. And this is a cross section. You can see this is the upper house. The upper house is there. And this is quite steep. You come to the lower ground. And then you even have a river at the bottom there. Therefore, what you're talking about is that there's a lot of underground water, as you can see over there. It's a lot of underground water, as you can see. And if you try to pump it, it should be trained enough to be able to be useful. So that is all that water is underground. All that is underground water, and it is you need to know where to take it. Therefore, is design in anticipation for the effects of that water. So these two buildings, the building on top there, the challenges anticipated there would be very different. And from the topography, the ground here, behavior is totally different from the ground there, because for you to be able to build up, then most likely this is borrowed ground, and therefore there are certain anticipated. In case of any movement, then the lower ground, the lower house would be expected to have more challenges. So we want to look at what kind of challenges do you anticipate in a scenario like that. If the place is not properly drained, you'll find that on the lower ground, there will be issues of rising moisture, rising damp, so you'll find the painting starting to bubble. That would be one of the things, an indication that there's a lot of underground water which needs to be properly trained and drained. You could also have, for example, in cases of any movement, especially if the backfilling was very high and predominantly consolidating soil, once in a while you may experience those kind of faults, but you need to look and ask yourself, are they structural? Are they on the main structure, or are they on the infill? It's very important to consult your structural engineer to help you. And this kind of cracking may be different. They may vary. And you need to look at their patterns. Where do they begin? Where do they end? Are they growing? Are they expanding? And you again go wall by wall where those are found, and your structural engineer will be able to advise whether this is structural or non-structural. If it is non-structural, we are assuming that the structure was properly done, the foundations were properly reinforced, and they were able to take, and they're in equilibrium. But what is taking the stresses now are the infill non-structural walls. What do you do about them? Some could even be bubbling and growing, and therefore you need to again be very careful and very vigilant to study where do they begin, where do they end, and when they end, the others, where do they begin? Do they begin where the other cracks were? And that is telling a story. This may even look very serious, but you need to interrogate, where does it begin, where does it end? And the branches, the tributaries, are they due to now that weak area, or they are fresh ones? So you must again look at the tributaries. Where do they begin? Where are they going? Have they started up there? And interrogate also the quality of your infill. And to do that, to mark the areas with cracks, so that you, after a while, after maybe even after a whole year, you need to observe whether they are growing, and also to allow them to settle fully, to consolidate fully, to look outside and make sure that there is no water coming to undermine your foundation and cause issues. So you mark the areas with cracks to be hacked all around, and then you hack the marked areas carefully using a very sharpened grinder, as you can see, and again inspecting to see that that activity is not causing other problems. Are the rest of the surfaces intact? And you continue like that and give the walls or the areas which have been affected time to settle down. And you continue until you clean out the debris, dust off the hack surface, and expose that area. You may find that the faults were actually on the mortar itself. You inspect whether it's the masonry that is weak, and after exposure you'll be able to tell what was the cause of these faults. And you continue and carefully install a wire mesh inside the hacked section or the hacked area so that it's able to take the tension. You place it neatly around. You continue until it's properly anchored, then replaster the area with the correct mortar consistency to avoid segregation, and then allow the mortar, the replaced mortar, to cure. So you must allow it to cure, give it time, splash with water, cure the repaired surfaces by splashing clean water with a paint brush for a minimum of 14 days. Don't be in a hurry. You allow it to fully cure. Curing means that the cement and the sand and the blocks are added together. So that's just a demonstration to show how this is done. All right. So you just brush carefully and also making sure you inspect the other walls. You splash carefully, and then of course you allow the repair section to either dry naturally for at least 30 days. You can also accelerate the drying by blowing hot air for at least 3 days. You can blow the hot air depending on the humidity on this area, the humidity within the house. You can blow the area. This is called accelerating drying, or there's no hurry in retrofitting. And remember, this usually happens to the building on a ground that has consolidating earth, because with time, when the air comes out, the building consolidates. As you can see in these ones, then you find the affected areas are in the middle. They are within a wall. They don't cross any structural edge. That until all the areas are dry. After they are dry, then you proceed with skimming the repaired sections, where skimming is as shown. Very careful, that is skimming.
Yeah?
You can see the skimming, how the
Ati
skimming
nyachaku.
is done carefully.
Chinyombo.
It's almost similar
Umu
to
Africa.
makeup, like how you do makeup. Make sure that it's completely flat, it's completely smooth. You can't see where these areas were. Skimming is done before the final painting.